All right, here goes number 45. Ethanol melts at, boils at. The fusion, enthalpy of fusion is, enthalpy of vaporization is, specific heats of solid and liquid are, respectively. Letter A, how much heat is required to convert 42 grams of ethanol? So we have 42 grams right here. Whoops, 42 grams. And 3 sig figs, so we're going to end up with 3 sig figs at the end. 35 to 78, I'm sorry, 2 sig figs right here, 2 sig figs, so we'll end up with 2 at the end. 35 to 78, so 35, that's a liquid phase, to 78 right here. So if we graphically represent this, here's the amount of energy on the horizontal axis, here's the temperature on the vertical axis. We're starting at 35 degrees, it should be right here. I wrote it down here by accident. And then we're going to heat it up to 78, and at 78 it's going to boil, or change to a gas, vaporize. And so completely vaporized throughout the liquid. And so then this is going to involve a temperature change. So this is going to be our equation Q equals mc delta T. And then when we boil, it's going to be the enthalpy of vaporization times the number of moles that we have. So first equation, mass is 42. Just knowing that we're going to end up with 2 sig figs, I'll write that, times the specific heat capacity of the liquid, which is liquid alcohol, 2.3 joules per gram Kelvin. And then times the change of temperature, and we're going from 35 all the way up to 78. So we're going to change it 43 Kelvin, or 43 degrees, because we go 43, even though they don't use the word degrees for Kelvin. Multiply those guys together, and then we have to convert that to kilojoules, because this is going to end up being in kilojoules. So it's about 4,200,123 this way. It gives us about 4.2 kilojoules for that process. Now when it boils right here, we're going to take our enthalpy of vaporization, which is 38.56 kilojoules per mole. I think that gives it to us right here. And then we're going to multiply it by the number of moles we have. And we have 42 grams, and there are 46 grams in 1 mole on the periodic table for that. And we multiply those together, and we get about 35.2 kilojoules. Now we have to take these 2 kilojoules right here, and we add those together to get our total energy. So our energy total would be equal to 39.3 kilojoules. So notice the 2 equations that I used. One for when there's a temperature change going on, one for when there's a phase change going on. In letter B, we'll see 2 phase changes, and we'll see 2 times when it's just changing with the temperature. So how much heat is required to convert the same amount of ethanol, so 42 grams once again, negative 155 to 78. So here's negative 155. And heat it up until it melts, which is at negative 114. It told us that right here. And then we're going to heat it up again until it boils, which is at 78. And then we're going to boil it right here, or change it from liquid to a gas. So when we have a temperature change going on, we use MCAT, mc delta T. And then right here and here, where we have a phase change going on, then we have the equation delta H, vaporization, or in this case fusion, because we're going from a solid to a liquid, times our number of moles. So this equation right here and here. So let's run through each one of those, and I'll pick the information off kind of quickly because you can look at it here in the document. So first of all, this one, 42 grams, M, times C, our specific heat capacity of solid is 0.97 joules per gram Kelvin, and then we change it from negative 155 to negative 114, which a change there is 41 Kelvin, and then we end up with 1,670, which is in joules, but we want it in kilojoules. So 1, 2, 3, so 1.1 let's round it, 1.7 kJs to 2 sig figs. So that's the first one. Second one now, delta H for the solid, so the enthalpy of fusion is 5.02 kilojoules per mole. And then we multiply that by our number of moles, which there's 42 grams, and we said in 1 mole there's 46 grams. We multiply those guys together, and we end up with 4.58 kilojoules. That takes care of this area. Now we're back to MCAT right here again, so 42 grams times, now the specific heat capacity is for the liquid though, so be careful. The liquid now has a specific heat capacity of 2.3 joules per gram degrees Kelvin, or just Kelvin. Don't use degree for Kelvin. And then we're going from negative 114 up to 78. So we have a change of 192 Kelvin. And this is going to be in joules, but we'll want to convert it to kilojoules. So it's 7.2. So 1, 2, 3 to the right gives us 18.54. 5 or more round up, so it would be about 19 kilojoules there. And that takes care of this part. And then the last part right here is the boiling part, or the changing from liquid to gas to vaporization. So the enthalpy of vaporization is, well, we actually did that right up here. We changed it from liquid to gas, this times 42, and so we know that that's 35.2 kilojoules for that change going on. Now, to find the total, we got to add all of these together, and so the total energy required is about, when we round, 60 kilojoules when we round to 2 sig figs. So I put 60 decimal point, or 6.0 times 10 to the first kilojoules in correct number of sig figs.